Welcome to the project demonstration of automatic speed controller for fan and coolers. So here we are representing this cooling fan as a speed controlling purpose. So this is the DC fan, so which is operated at 12 volts. So here the main purpose of this project is whenever the room temperature increases, then parallelly we are going to increase the speed of this fan in order to cool down the room temperature. So that will be achieved by our PIC 16F72 microcontroller. So it's keep on monitoring the room temperature with the help of LM35 temperature sensor, and based on the temperature values, when it's keep on increasing, so then automatically we are going to send up PWM signals to this DC fan to increase the speed. So to increase the speed, we need to increase the on time. In the PWM signal, there will be two sections, on time and off time. When the on time is increasing, then the duty cycle increases, so that parallelly the speed of this DC fan will be increases. So whenever the temperature comes down to normal condition, again we need to decrease the on time so that the fan speed also will be decreased. So here for the controlling purpose, the microcontroller will take care of the temperature sensor which is connected at A0 pin, and the output for the fan is connected at C2 pin through this transistor board. So as we know that transistor will act as a switch in our project. So based on this on time and off time controlling signal given to this transistor, the transistor also will on and off the power supply to this DC fan directly. So here the so-called status of this temperature values will be displayed on the 16:2 LCD screen directly, which is interfaced at pin number B2 to pin number B7. So the whole system getting power supply from this transformer. 230 volts AC is input to this one, and the transformer will provide us the 12 volts AC output to this regulated power supply board. So it has a three stages. First is the rectification. With the help of these four diodes will act as a bridge rectifier. So we will get pulsating DC, and after that pulsating DC input to this capacitor, which will act as a smoothing purpose, so which will remove those pulses, so we will get a pure DC voltage of 12 volts, and our microcontroller need 5 volts. So for that purpose, again we are using a 7805 regulator. So after the 705 regulator, we will get the 5 volts constant DC power supply. So that is the main power source input to the motherboard, LCD, fan and temperature sensor also. So as we discussed, RPS consists of rectification, filtration and regulation. So 5 volts we got that. Coming to this motherboard, so there are the three major components now. One is the microcontroller, as we discussed the PIC 16F72 microcontroller, and a crystal oscillator. So the main purpose of this crystal oscillator is which will provide us the 20 megahertz clock frequency to the microcontroller. So the 20 megahertz nothing but this clock pulse is needed for the microcontroller to execute the instructions. So per instruction, controller will take one pulse, so that the controller can execute 20 mega instructions per second, as we are providing 20 mega clock frequency per second. So this is the reset switch, just to restart the microcontroller. Press and release, the control will restart. So let us see the demonstration. So just provide the 230 volts AC input to this power cable. Then initially the welcome message will be displayed on the LCD screen. Right. So now the temperature is 28.8 degrees centigrade. So when we are trying to increase the temperature by placing a heat object, so we can observe the fan start rotating. As a normal temperature, fan is in low speed, nothing but off state only. So when the temperature keep on increases, the fan speed also keep on increases. Again, when its temperature comes down to normal condition, fan speed also comes down to normal speed. Right, so that can be observed by the fan rotations. Right. So in this manner, we are going to control the speed of a DC cooler or a DC fan based on the room temperature by using the PIC microcontroller.